derivative of both sides. We just weren't always writing it. So here, this isn't in y equals form, but we're going to do the same thing. We're going to take the derivative of both sides of the equation. Now what's d dx of x squared? 2x. The derivative of x squared in terms of x is 2x. Or, using the chain rule, knock, 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 who's at the door?
2.
I don't know yet. I got to do the 2 first. You know what I'm saying? Who's inside? I'm not sure yet. I got to bring down the 2. X raised to 1 times the derivative of what's inside. What's d dx of x? What's dx dx? 1. Does that make sense? So times 1. Plus, or I'm going to write it as d dx of x for now. D dx of x. Plus, I'm taking the derivative of this function. What's the derivative of this thing?
2y times y times.
Yeah, I don't know yet. You know what I'm saying? Same rules. Who's inside? Who's there? I don't know yet. I got to do power rule before I can take the derivative of what's inside. Does that make sense, Estella? So this would be bring down the 2, leave what's inside alone, following the chain rule. I don't know yet. Times the derivative of what's inside. Equals, what's d dx of a constant? 0. Okay? Now let's look at what we did here. 2x times, again, d dx, or dx over dx. That's the same thing. So they just kind of cancel out. That's 1. Does that make sense, you guys? So this is just 2x like we've been doing all along. Plus 2y times, what's d dx of y? Yeah, that's dy dx. That's what we've been doing. That's derivative. Change in y over change in x. Here's your derivative equation. Now, if you don't like it in this form, if you like it in y prime form, let's put it in y prime form. What's the first thing I would do? This is an algebra problem now. Do you know what I'm saying? Magali? Once you get in this form and you're solving for y prime, there's no more calculus involved. It's just algebra. So what's the first thing you would do, Lauren?
Subtract the 2x.
Yeah, subtract 2x from both sides. Then what would you do, Jackie Brooks?
Divide
2y, yeah, divided by everything. Y prime equals negative 2x divided by 2y, which simplifies to what? Negative x over y. What is this an equation of? What is this thing? What is this thing that I just wrote? What is it? Is it a pickle sandwich? Yeah, this is an equation or a function that'll give you the instantaneous rate of change for any point on the circle. That's what you just solved for. Does that make sense? Now, why does it have an x and a y in it? Does that make us sad? When I did this, do you see I did y equals x squared plus 5? The derivative only depended on the x value. You give me an x value, I'll tell you the rate of change. At this x value, it's like this. At this x value, it's a number like that. Why does this have an x and a y in it? Lauren.
Because it's a circle and it has an x and a y value because you can have more than one point.
Yeah, let's check the places. At 3, well, which 3 do you mean? Do you mean this? Do you mean this 3 or this 3? See how the tangent lines are different? You see it? For the same x value, you have different rates of change. It depends on the x and the y value. If you check this y value, positive 4, with this y value, negative 3, this is point negative 3, 4, these have the same y value, but different derivative values. See how this one's going to be positive, that one's going to be negative? The math's not telling you jokes. It's not saying, what's a chicken's favorite nut? What's chicken's favorite nut? Pecan! It's not telling you these jokes. It's telling you exactly, it says, hey, I need an x and a y value. Does that make sense? In this case, you just need the x value. Do you see it? You give me an x value, I'll tell you what the derivative is. But this derivative depends on x and y. Does that make sense, you guys? So let's solve for it. At the point 3, -4, what is the instantaneous rate of change? What is the slope of the tangent line? So -3 over 4. Is that what we solved for here? It's the same. This is the rate of change at the point 3, -4 is positive. Negative is positive 3/4. Which we solve for using our knowledge about circles, tangent lines, normal lines, and all that stuff. Does that make sense, you guys? Now, again, if I just gave you in the beginning, I want to know the instantaneous rate of change at x equals 3. Before, what would you have to do? Before you took the derivative to solve for the slope of the tangent line. What did we always do first when we were given at x equals 3? Yeah, we solve for the point. In order to create a tangent line, you need a point and a slope. And then you dump that into point slope. If you're just given an x equals 3 value, well, you plug 3 in for x, you get 9 plus y squared equals 25. Subtract 9 from both sides, y squared equals 16. So y equals what? Plus or minus 4. Can you see that? And the circle will give that to you. If you square root both sides, you get plus or minus 4. That's where you get 3 positive 4 and 3 minus 4. So a lot of times, for a lot of things like circles and whatnot, you need to be more specific. You need an exact point if you want to know the exact tangent line at a specific point. I just can't give you the x value. Does that make sense? Because for this x value, there's actually 2 points. Because it's not a function. It doesn't pass the vertical line test. Okay? Does that make sense, guys? How are we feeling with this stuff? Cricket? Yes?
That negative x over y for y prime, would that work for any circle of any radius?
Great question.
Like if that would, instead of a 25, that was like 100. It'd still be the same thing.
So there's 2 things you can look at. One is every circle centered at 0, 0. Every circle centered at 0, 0 would be x squared plus y squared equals whatever the radius was squared, a value. You take the derivative of that, it's always going to be 2x plus 2y prime equals 0. So would this be the equation for any circle centered at the origin?
Yeah.
Now, would it be if this was like x minus 3 squared plus y minus 4 squared? That, I don't know, maybe we need a little more investigative reporting on that one. Do you know what I'm saying? But just to leave your question as is, for any circle who's centered at the radius, or who's centered at the origin of any radius, sure. Do you know what I'm saying? This would actually be the equation. Because, I mean, you can just test it with that. If they're all going to be in the form, then x squared plus y squared equals a constant. And when you take the derivative, it's gone. You know what I'm saying? Okay, so it seems like we had fun with this. So the derivative is equal to negative x over y. But you know what? You know what I'm kind of interested in is, I want to figure out how fast that derivative's changing. So I'm going to take the second derivative. So let's do it. Sounds like a fun little